Have you ever looked up at the night sky and seen a bunch of stars in a sort of smudgy shape? You probably saw a galaxy. Chances are it was the Andromeda Galaxy or one of its galactic neighbors. But there are also other galaxies out there that look more like faint smudges than collections of stars. They are called ultra-diffuse galaxies, and they are some of the least understood structures in the entire universe. I'm the host, and this is my channel. While looking through photographic plates of galaxies from the 1950s, astronomers noticed some strange shapes lurking in the images. These objects weren't like any galaxies they had seen before. They were huge, much larger than our Milky Way, but they didn't seem to have any stars in them. At first, they thought these strange space blobs might be errors in the photographic plates or even flaws in the lenses used by the telescopes. However, as newer and better telescopes came online, the same weird objects kept appearing. They can only be seen because in some cases their outer edges contain a few bright pockets of stars that glow faintly in the darkness of space. If we could see inside these galaxies, we would likely find an empty road with very few cars on it. That's because ultra-diffuse galaxies have very low stellar mass. The average star formation rate is less than 0.5% of the rate in normal galaxies like ours. So, if we compare them to galaxies with more stars, their size is really mind-boggling. For example, one named Dragon Drop 2 has an extremely large radius of 660 kiloparsecs, which means it would take roughly 2 million years to travel from one side to the other. Yet, it contains around 40,000 times fewer stars than our galaxy does. That makes Dragon Drop 2 about 10 trillion times less luminous than the Milky Way. In fact, it's so dim that if we could move it closer to us, it would appear no brighter than the small faint stars known as red dwarfs. These massive galaxies are so hard to spot in the night sky that they were only discovered in the late 20th century, and as of early 2023, we've only confirmed the existence of about 100 of them. Most of the rest are candidate objects awaiting confirmation. And even though astronomers don't know exactly how many ultra-diffuse galaxies populate the cosmos, they do know that they're surprisingly common. A single region of space that scientists surveyed found 20 ultra-diffuse galaxies for every regular galaxy in the area. And while their total number is staggering, the amount of ordinary matter in them is tiny compared to the amount in normal galaxies. This is because most of their mass is contained in invisible forms of exotic matter called dark matter and dark energy. And here's where things get really weird, because not all ultra-diffuse galaxies seem to have the same amount of dark matter. According to observations by NASA's Chandra X-ray Observatory, some of these galaxies contain roughly twice as much dark matter as ordinary matter. By contrast, our Milky Way has about 5 times more baryonic matter than dark matter. Other ultra-diffuse galaxies like NGC 105 to DF4 have almost no dark matter whatsoever. Astronomers don't know why these objects have such different ratios of dark to ordinary matter, or whether they lines eventually find a way to reconcile the two. Even stranger, ultra-diffuse galaxies seem to be missing something else, namely the black holes that lurk at the center of most galaxies. The good news is that this doesn't mean you can go strolling through them safely. The bad news is that they don't seem to have any black holes for an unknown reason. And since those collapsed star cores play a crucial role in the life cycle of galaxies, this poses quite a puzzle for astronomers trying to understand how these space blobs evolved over time. In fact, the whole formation process is a complete head-scratcher. One popular theory among astronomers is that ultra-diffuse galaxies are actually dwarf galaxies that have been tidally stretched by the gravity of their larger neighbors. But simulations of this process don't produce anything that looks like an ultra-diffuse galaxy. What's more, astronomers have found some objects that look like the building blocks of these galaxies, but they haven't yet found any actual examples of ultra-diffuse galaxies forming in real time. And without a clear idea of how they form, it's impossible to predict how long they'll exist. According to some models, ultra-diffuse galaxies will slowly heat up and fall apart over billions of years. Others suggest they might continue to exist indefinitely, or at least until the heat death of the universe. This raises another: why don't they just clump together and form more normal galaxies? Well, one reason could be that they were already made of building blocks that were destined to become part of bigger galaxies. For example, a study from 2022 suggests that some of them are actually shells ejected from the centers of massive galaxies where stars were born and then blown away from their birthplace by supernova explosions. If this is true, ultra-diffuse galaxies could serve as a kind of cosmic Rosetta Stone, allowing astronomers to read the chemical record of how stars formed in the early days of the universe. They might also help researchers learn more about the role that giant black holes played in the formation of the first galaxies. After all, the only thing that might be able to prevent ultra-diffuse galaxies from collapsing into more normal ones is a supermassive black hole at their center, but without clear evidence that they have any black holes at all, let alone ones as massive as a few 100,000 times the mass of the Sun, it's hard to say whether this could be true. It's possible that these elusive black holes will remain hidden forever, keeping their existence a secret behind a shroud of dark matter. And while that might frustrate astronomers who want to solve the mystery of galaxy formation, it also reminds us that even when we think we have the universe figured out, there's always something left to discover. Okay, now it's time for some space trivia. What do you think? Are ultra-diffuse galaxies the remnants of ancient galaxies that have lost their stars, their dark matter, their black holes, everything but their gas? Or are they the building blocks of larger galaxies waiting for gravity to do its work? Let me know your thoughts. Then check out this video on one of the creepiest things in space, ghost galaxies, or this video also about galaxies. Don't forget to subscribe, and I'll see you next time.